Peace be upon all of you. Welcome students to my channel Physics is Fun for All. Hello, this is MD MINHAJ. Today's lesson is especially designed for Neet and JEE students and also for the other competitive exam of physics. So today's lesson is wave optics. Wave optics is a branch of physics where light is considered as a wave. This is part 1 of this course, and in this part 1 we will discuss 4 subunits mentioned in the next slide. So we will go into the next slide. So this is our next slide. The topic of discussion of today's lesson is, first of all, number 1, Newton's corpuscular theory. Number 2, Huygens wave theory. Number 3, wave fronts. And number 4, different types of wave front. So first of all, we will start the topic Newton's corpuscular theory. So let's start. So this is the slide for Newton's corpuscular theory. Newton's corpuscular theory was given by Sir Isaac Newton. So before we go into the detailed discussion, we will say a few points about this. The light is electromagnetic wave, as we know in these days, but the actual nature of light was not known to man since the ancient time. There was a confusion about the actual nature of light. Different scientists gave us different type of theory. Among the all, there is no one theory was complete theory of light. Similarly, Newton gave a theory which is popularly known as Newton's corpuscular theory, and this theory suggesting the following. The light is made of tiny and light elastic particles are called corpuscles, which are emitted by a luminous body. So we have to know the term luminous body. What is a luminous body? The body which emits light is called luminous body. In the next point, Newton suggests that corpuscles travel with speed of light in all direction in straight line. This is the Newton's second postulate. In postulate, he said that light travels in straight line in the form of corpuscle. In the third postulate, Newton says that corpuscles of light carry energy with them and produce sensation of vision when striking a retina of eye. So this is the Newton's third postulate. In the third postulate, Newton said that when corpuscle of light strike on the retina of eye, it produces sensation of vision. In the postulate number 4, Newton said that corpuscle of different color has different sizes. So this is the Newton's fourth postulate, which says that the size of the corpuscle is different for different color. As we know, in terms of wavelength, the wavelength of different color is different, and the wavelength of red is longer than the other color. Similarly, the size of the corpuscle for red color will be longer or larger than the blue corpuscle. In fifth postulates, Einstein explains that light carry energy and momentum, travel in straight line in vacuum, and laws of reflection and refraction with the help of this corpuscular theory. So, with the help of corpuscular theory, the different phenomena of light, such as reflection, refraction laws, and traveling of light in straight line in vacuum, and light carry momentum and energy, this is explained on the basis of corpuscular theory. And Newton's also said in the corpuscular theory that the velocity or the speed of light is more in denser medium. So these are the basic postulates of Newton's, which explains different properties of light. Now we see that there are different types of properties which is solved by light, and we see that some of them are explained by the corpuscular theory, but rest of them, such as interference and diffraction and polarization, was not explained by this corpuscular theory. And also we know by our later investigation that velocity of light, speed of light is smaller in denser medium and larger in the light medium, or the medium which is small denser. But this contradicts the corpuscular theory, and for this true reason Newton's corpuscular theory was rejected, and we have a necessity of new theory. And to overcome this drawback of this corpuscular theory, Huygens gives us a theory which is known as Huygens wave theory. We'll see in the next slide the Huygens wave theory. So this is our next slide, the Huygens wave theory. So this Huygens wave theory was given by Christian Huygens, and according to this theory, a luminous body is a source of disturbance in a hypothetical medium called ether. This medium pervades all space. That means Huygens said that all source of light create a disturbance, and it propagates in a hypothetical medium called ether, and this ether medium is spreading over all space. But in the later experiment, it was shown that there is no existence of ether medium, which we will discuss in our chapter of relativity, and which is the topic of higher physics. And this non-existence of ether was experimentally confirmed by Michelson and Morley by his famous experiment. And the next postulate of Huygens theory is that this medium is transparent and having no inertia. So in the assumptions of Huygens, Huygens assumes that the ether medium is transparent and it has no inertia. So the property of the ether medium is transparent and having zero inertia. And in the third postulate, Huygens said that the waves carry energy and momentum, and Huygens assumed that waves were longitudinal. In the third postulate, Huygens assumed that waves are longitudinal, but when we investigated about the polarization effect of light, we will observe that light is not longitudinal waves, light is a transverse wave, which is experimentally confirmed on the polarization phenomena. Now, observe point 3 carefully, that this point 3 is similar to the point number 5 of Newton's corpuscular theory. Newton's corpuscular theory also says that corpuscles carry energy and momentum. So there is a similarity between these two assumptions of Huygens and Newton's. So we will see the next point of Huygens wave theory. So this is the next point, that is point number 4. So we will see the point number 4. The Huygens wave theory explain successfully the phenomenon of interference, diffraction, apart from other properties of light. That is, we see that in corpuscular theory of light, the different properties of light, such as reflection, and propagation of light in vacuum, were explained successfully by the help of corpuscular theory. Similarly, these all properties, all phenomena, also the extra phenomenon of interference and diffraction of light, is explained on the basis of Huygens wave theory. The next assumption of Huygens, that these waves are longitudinal, which we discussed in previous point. Now the fifth point is Huygens wave theory fails to explain photoelectric effect and quantum effect. We will learn in our next chapter of physical optics. There are two types of phenomena, namely photoelectric effect and quantum effect. This could not be explained with the help of Huygens theory, because this will be explained in the dual nature of light, that means de Broglie hypothesis, and it could be explained on the basis of Einstein theory, and this photoelectric and quantum effect also can be explained on the basis of particle nature of light. And number 6 point is concept of wavefront. That means Huygens introduced a new concept of wavefront, and in the next slide we will learn more about this wavefront. What is wavefront and what is the nature of wavefront? We will discuss one by one this topic. So there are some point of wavefront. So we will discuss one by one. So first of all, we will know what is wavefront. According to Huygens, the locus of all particles in a medium vibrating in same phase is called wavefront. So Huygens suggests that the locus of all particles in a medium vibrating in the same phase. So we have to notice the word locus. What is locus? Locus is the connecting between different points. If we consider, or if we assume a plane between different points, then we will say that this is the locus of that point. So this locus can also be termed as trajectory. That means the path through which any particle moves forward. So this is the locus, and the line connecting the point of same phase is also termed as the locus. So this is very important to remember. The next point, that the direction of propagation of light or ray of light is perpendicular to the wavefront. That means the next or the third point was to say that the direction of propagation of light is along the straight line and is perpendicular to the wavefront. And here we have to focus on the term ray of light. So if you asked the definition of ray of light, then the definition will be the line drawing perpendicular to the wavefront is known as ray of light. The next point or the fourth point of wavefront is every point on the given wavefront acts as a source of new disturbance called secondary wavefront, which travel in all direction with the velocity of light in the medium. That means in the fourth point, I can want to say that every single point is act as a source of new wavefront, and this new front is known as the secondary wavelet or secondary wavefront, and the wavefront which is produced from the secondary wavelet is known as secondary wavefront. And this topic will be more precisely understood on the help of a diagram of wavefronts, which we will discuss in the next slide. So we will go into the next slide and we will see the diagram of wavefront. So carefully observe this diagram. Consider that this is a point source. So take a pen. So this is our point source. That means light is emitting from this point. Now light will propagating in the forward direction. That means this will go along this line, also go along this line, and along this line, and this line also. So these are some lines in which light is propagating. Now if we consider this black line excepting the red line, then we'll consider these point. So this point, this point, this point, and this point, and these total 5 points are in the same phase. Now if you join these point with a line, then you will obviously obtain the locus. So this locus of the same phase point line is known as the wavefront. So this locus is the primary wavefront. That means the wavefront which is produced initially is known as primary wavefront, and the wave produced from this primary wavefront, from that is this point, is known as secondary wavelets. So this is our secondary wavelets, and this secondary wavelets goes after some time t to this new point. So this is the new point. So this is the new point, and at this point new wavefront will be formed, and this wavefront is known as the secondary wavefront. So you have to remember an important point, that there is no existence of back wavefront. That means this wave cannot travel in the backward direction. So you have to remember that there is no existence of backward wavefront. The wavefront only propagate in the forward direction. Okay, so hope that all of you understand the concept of wavefront. Next we will go into the discussion of different types of wavefront. So this is our next slide. In this slide we will see that different types of wavefront. We know that source of lights having different shape. Some of the source can be point source, some of source can be line source, and in another shape, and some light source can be situated at infinity. And with the basis of this different type of source, different types of wavefront are emitted from this different type of source. So first of all, we will see in the column number 1 types of wavefront. Sorry, this is types of wavefront, and in the next column intensity of light, and the third column the amplitude of light. So in this first column we see that the nature of the wavefront is spherical type. So this is the spherical wavefront. The spherical wavefront is basically emitted from the point source. That means if the light source is a point source, then it will emit spherical wavefront. So this point, if you see, this point is the point source, and from this point source a spherical wave is emitted along the both direction, and it is propagated along the wall direction. So this point source is the denoted as this point source, and from this point source this spherical wavelet or wavefront is emitted, and this straight line drawing on the wavefront is the light ray. Now by mathematical calculation it is seen that the intensity of light, that means the amount of energy content per unit volume of light, is inversely proportional to the square of the radius of the spherical region. So if the radius of the sphere is increased, then intensity of that light will be obviously decreased. And as we know that intensity I proportional to capital A square, that means intensity I is proportional to amplitude square. So from this equation you will calculate that capital A will be inversely proportional to 1 by R. Similarly, in the second row the cylindrical wavefront is discussed. So we say that if the source is line source, that this is line source, then from this line source cylindrical wavefront will be emitted. So this is the line source, and the cylindrical wavefront is showing here, and the arrow is showing the light ray. So in this cylindrical wavefront the intensity is inversely proportional to the radius of the cylinder, and amplitude is inversely proportional to the square root of the radius of the cylinder. Now in the third row we will see plane wavefront. We said that if the light source is the light source is situated at infinite distance apart, then this line source will emit the plane wavefront. So this light is coming from infinity. So this light is coming from infinity, and this is showing the plane wavefront, and this is plane wavefront, and this is the arrow which shows the light rays. So in the case of plane wavefront, the intensity is independent of the distance, and so I proportional to r to the power 0, and amplitude also proportional to r to the power 0. So this is all about different types of wavefront, and hope that this video is very helpful for all of you. And from this discussed topic I arranged some question which is very important for exam purpose in the next slide, and we will discuss the question one by one in the next slide. So we will go into the next slide. So this is our next slide. Important question from this topic. The first question could be asked that why Newton's corpuscular theory. So sorry, this will be corpuscular. So there is a error in spelling. So why Newton's corpuscular theory was failed. So we have discussed that Newton's corpuscular theory could not explain the interference diffraction, so it field. What is wavefront? We have already discussed the definition of wavefront in the previous slide. And the number third, what is secondary wavefront? We have also discussed about secondary wavefront. Number four, what is back wavefront? We have also discussed about the back wavefront, and we also say that there is no existence of back wavefront. Similarly, we also discuss about the necessity of wave theory. So we have to give the reason of failure of Newton's corpuscular theory and necessity of analysis of the wave theory. And the sixth question, what's drawback of wave theory? You have to explain that polarization effect and the Compton and photoelectric effect could not be explained on the basis of wave theory. So this wave theory failed, and a new theorem is come in the branch of physics, which we will learn in our next class. The seventh question is, how many types of wavefront are there? We have discussed basically three types of wavefront in our lesson. And eighth question is, what is shape of wavefront for light source situated at infinite distance? So we have also already discussed in the last that for source situated at infinity, the wavefront will be of plane wavefront, and the shape of the wavefront will be plane. So plane wavefront is for source of light situated at infinite distance. Okay, so hope this is very helpful video for all the students, and all of you are requested to subscribe this channel and like this video, and don't forget to comment and also share this video. Thank you for watching.